let's come up here. Okay. I guess a lot of you are thinking in the right direction, but let me give you the final solution as well. Okay. Now, how to derive the time complexity of merge sort? Okay. If you carefully analyze merge sort, then you will realize one thing, that you have an array, you divide your array into multiple parts, 2 parts here. Then each 2 part is divided into 2 more parts, making it 4 parts. Then each 4 part is divided into 2 parts, making it 8 parts, and so on. Can I say that? So, can I say that, let's say if I write level here and length of the array here, number of parts here, and let's say work done here. Work done is how many iterations you are actually doing. Okay. Oh, sorry. The camera is not brought up. 1 second. Okay. So, what we can say is that on the 0th level, the length of the array is n. Can I say that? Length of the array is n. And there is only one single array that is under consideration. On level number 1, the length of the array becomes n by 2. And how many such arrays are there? There are 2 such arrays. On level number 2, there is the length of the array becomes n by 4, and there are 4 such arrays. Can you see? 4, right? On level number 3, length of the array is n by 8, and there are 8 such arrays. Can I say that? And so on. On some level k, length of the array will be n by 2 raised to the power k, and there will be k such arrays. Can I say that? Yes or no? Okay. Now, if k is the final level, then length of the array is 1. Can I say that? If k is the final level, then on the final level, length of the array is 1, because that's the base case. So you can say n by 2 raised to the power k is equals to 1. N is equals to 2 raised to the power k. Taking log both sides. Log n base 2 is equals to log 2 raised per k base 2. This is k log 2 base 2 is equals to log n base 2. This is k is equals to log n. Can I say that? Log 2 base 2 is 1, so k is equals to log n. So we know that if we keep on dividing our array like this, how many levels of division we will get? We'll get log n levels of division. Can I say that? Okay. Now, if you have k arrays, Rushikesh, which part? फ्रॉम स्टार्टिंग क्या हुआ? लेट आए, सुना नहीं, क्या हुआ? पहले बताओ क्या हुआ, फिर मैं बता तो मैं दूंगा, पहले बताओ क्या हुआ. अभी मैं शुरू से कर रहा हूँ रिपीट शैतान, बट ऋषिकेश से पूछ रहा हूँ कि क्या हुआ, स्टार्टिंग से क्या मिस किया आपने, कहाँ मिस किया, क्यों मिस किया? बोलो ऋषिकेश. सो अगेन मेंशनिंग, प्लीज कीप योर फोकस है. साथ में फोन चलाओगे, बेड पे लेटे रहोगे, नोट्स बनाने की कोशिश करोगे, मम्मी ने बुला लिया, पापा ने बुला लिया, दोस्त ने बुला लिया, ये सब अगर पैरेलली चलेगा, हफ्ते के 6 घंटे, 2-2 3-3 घंटे की 2 क्लास है, इन 6 घंटे आपको अवॉइड करना है, फोकस से बैठे. ठीक है? सो विद योर अनडिवाइडेड अटेंशन, आई एम टेलिंग यू अगेन. सो आई एम राइटिंग 4 थिंग्स हियर. Level, length, number of parts, work done. Park work done for some moment. We'll come back to it. On level 0, this is level 0. What is the length of the array? Length of the array is n. So I've written length of the array is n. And how many arrays of length n is there? There is only one array of length n. So number of parts is 1. On the next level, that is level number 1, what is the length of the array? N by 2. Can I say that? Because we divided the array into 2 n by 2 length arrays. And how many such arrays are there? 2 arrays. Can you see? 2 arrays. Right? पूरा टाइम फोकस नहीं हो पाता. That's something that you have to improve on. Adi, that is something that you have to improve on. As a student, तुम्हारा ये आई वुड से स्किल होना चाहिए दैट यू आर एबल टू फोकस फॉर एटलीस्ट 3 आवर्स. मेरे को ऐसा लगता है. तभी जेई की क्लासेस 3 घंटे होती थी. मैं भी ट्राई करता हूँ 2 से 3 घंटे क्लास रहे. अगर तुम 3 घंटे फोकस नहीं कर सकते तो मेक श्योर कि यू एम लेस ऑल्सो. अगर एम हाई है तो फोकस हाई होना चाहिए, वरना एम लो रखो, कोई दिक्कत नहीं है. एम फॉर समथिंग सिंपल, इट विल बी गुड. इफ यू एम हाई देन मेक श्योर योर फोकस इज ऑल्सो हाई. फोकस 3 घंटे नहीं है तो सोचो भी कब कि भाई मतलब हम तो कम में ही सेटल करेंगे. अगर ज़्यादा में सेटल करना है, you need bigger packages, you need better company to work in, you need to make your own startup which is going to be multi-million dollar maybe someday. You have to focus more. ये कह देना कि फोकस नहीं हो पाता, मतलब विराट कोहली अगर हर मैच में जाके बोल दे कि नहीं मेरे से बल्ला नहीं चलाया जा रहा बट मेरे को खिलाओ, तो क्या इंडियन क्रिकेट टीम खिलाएगी? अब बस ये सोचो, अब विराट कोहली हुए क्रिकेट खेलते हैं जो शाम को होता है ना, हर 5 साल में वो 10-12 लाख मुझे इतना पता है बैच 80% 90% इज इन कॉलेज। कॉलेज के बच्चे मेरे को कोई भी दलील देना कि मेरे पास टाइम नहीं है, और कॉलेज प्लेसमेंट की कंपनी है उसमें तुम काम कर, यू कैन नॉट ब्लेम एनीबडी एल्स फॉर आईटी। ठीक है, इसी यूनिवर्सिटी से मेरा भी सेम कॉलेज है, तो मैं तुम्हें 2016 30 और स्टार्ट फ्रॉम द नो हार्ड वर्क नहीं करो लगती। On level 0 we have n by 2 raised to the power 0. On level 1 we have n by 2 raised to the power 1. On level 2 we have n by 2 raised to the power 2. On level 3 we have n by 2 raised to the power 3. So on some level k we will be having n by 2 raised to the power k. Can I say that? Right? And here also 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. So how many parts will be there? 2 raised to the power k parts will be there, yes or no? And if k is the final level, then we know the base case. Base case comes when the length is 1, that's the final level. So technically n by 2 raised to the power k, which was the length, we can equate it to 1, taking log both sides. Log n is equals to log 2 raised to the power k. K comes here in the multiplicative factor. K log 2 base 2 is equals to log n. K is equals to log n. So can I say total levels in worst case will be log n? Yes or no? Yes or no? Okay. Now, if I can calculate the work done or number of iterations on each level, then we can just add them up, right? Okay. Now, let's think about it. To get this level, can I say I will be merging, when I will be merging, I will be merging two arrays of n by 2 length. What was the time complexity of merge two sorted arrays? It was m plus n. Here m is n by 2, n is n by 2. So the total time complexity is order of n. Can I say that? Think about it. If you have to merge two arrays of n by 2 length, what's the time complexity? N by 2 plus n by 2, that is n. So can I say to get this level, you do order of n time? Can I say that? Shubham, I'll answer that in a moment. Very nice question, but I'll answer that in a moment. Okay. Guys, is this point making sense? Okay. Now, to get these two arrays of length n by 2 and n by 2, you will be merging these arrays of length n by 4. How much work done will be there? To merge two arrays of length n by 4 to get an array of length by n by 2, it will be order of n by 4 plus n by 4. And here also, to get an array of length n by 2, it will be an order of n by 4 plus n by 4. So order of n by 4 plus n by 4 plus order of n by 4 plus n by 4 will be order of n. Can I say that? So to get this particular level also, we'll be doing order of n. This particular level also order of n, and so on. So you are doing n iteration on each level. And how many levels you have? You have log n levels. So if you are doing n iterations on each level and you have log n levels, time complexity is this, order of n log n. Are you able to get this point? Are you able to get this point, guys? So that's the time complexity. And this time complexity will be the same for the best case also and the average case also. Because every time doesn't matter, even if the array is sorted, then also you keep on dividing the array into two parts, and you keep on merging them. Does that point make sense? But an interesting question comes up for the space complexity. What will be the space complexity? So there is a very interesting article from Stack Overflow. If you will search for merge sort space complexity Stack Overflow, so they have there is one very interesting article where the author has given some very nice diagrams. Yeah, this one. When you visualize merge sort, you think something like this. Can I say that? You had an initial 16 length array, then two 8 length arrays, then 4 length arrays, and so on. And so on. Yes or no? That's how we were visualizing merge sort, yes or no? But if you carefully analyze and if you carefully remember how we did the dry run of merge sort, can I say this is not happening parallelly? Yes or no? All of these branches are not working parallelly. Can I say that? These branches were not working parallelly. Remember, when we had 3, 2, 1, 0, we first of all went and sorted 3 and 2. Then separately we went and sorted 0 and 1 and then merged both of them. It was not like 3 and 2 was parallelly being worked with 0 and 1. No. You will first of all from here, go here, then go here, then come back, then go here, then come back, then go here, and so on. And you can see the same representation the author has also given. In this, the author says that this is not the actual case. In the actual code, it doesn't execute in parallel. Yes or no? Yes or no? So how does it execute? It will execute one individual branch. So from 16, you have the left half, then you have the left half, then you have the left half. This left half gives you the left half as a base case, and the right half is the base case. Can I say that? So at any point of time, what is happening? There is one space of recursion because recursion uses call stack. So you are using the call stack. Yes or no? How many entries will be there in the call stack? Can I say the number of levels? It will be equal to the number of levels. How many levels are there? Log n. So at any point of time in the call stack, you will be having log n entries. Can I say that, guys? At any point of time in the call stack, you will be having log n entries. But apart from the call stack, do you remember we are making these resultant arrays? This is also extra space, right? This is also extra space. Can I say that? What about that? So that's what the author is mentioning here. If you carefully see, let's say you are having a 16 length array, then you divided it and have the left part as 8, then 8's left part as 4, 2, 1 and 1. If you sum this up, what you will get? 16 plus 8, 24, plus 4, 28, plus 2, 30, plus 2, 32. Can I say that? Can I say that? And can I say 32 is less than 3n? 32 is less than 3n. Yes or no? Okay. Then in the next step, now this part is done. This part is done. And you have, and this memory will be removed because now you have merged this part. Can I say you will come up here? Now you'll go to the right part. 32 less than 3n means they are keeping an upper bound. They are getting a value that, okay, whenever you will sum up the space, this space will never be more than something. More than what? So you can see 32 can never be more than 3n. It will be always less than 3n. Now let's see here. 16, 8, 4. The left half of 4 is now sorted. Can you see? The left half of 4 is now sorted. I'll come to why 3n. Can you see? The left half of 4 is now sorted. And now you're trying to sort the right half of 4. Can I say that? So at any point of time, how many arrays will be there? This 16 length array, plus 8 length array, plus 4 length array. This becomes what? 28, plus 2 length array, 30, plus 2, 32, plus 2, 34. Can I say this value is also less than 3n? Now you might be thinking why the author is always talking about 3n. Because we want to look at the space complexity with respect to the input size. Input size was n. So we are trying to figure out a value which will always suffice the fact that the total space of the arrays is never greater than which value. You can see it is definitely greater than n. It is definitely greater than 2n, but it is definitely less than 3n. So it's kind of like a trial and error that the author is actually trying to figure out, okay, it's always less than 3n. Now let's go back. Now you can see this array will be sorted. Now you have left half sorted, you have right half sorted, you merge the two halves. And that's when the next step comes up. Can you see? The left of 8 is now sorted. Now you're trying to sort the right of 8. Again, can you see? The total space is less than 3n. Yes or no? Then again, in the next step, the total space is less than 3n. So always and always, the total number of arrays at any point of time in the memory will be less than 3n. So this value x will be always less than 3n. So what is the total space? X plus log n is the total space, where x is always less than 3n. It can be 2n, it can be 2.5n, it can be 2.n, 2.6n, anything. This is the total space. So if this is kind of like some kn plus log n, where k is always less than 3, you can write it, right? Kn plus log n, where k is less than 3. K is a constant term. It will be 2, it can be 2.5, it can be 2.7, it can be 1.5, anything. It's a constant term. So this becomes n plus log n, and log n is a lower degree term because at a scale of 10 raised to the power 3, 10 raised to the power 3 plus log of 10 raised to the power 3 is what? Log of 10 raised to the power 3 is 10. So 10 raised to the power 3 plus 10 is what? 10 raised to the power 3. If let's say you have 10 raised to the power 6, then 10 raised to the power 6 plus log of 10 raised to the power 6 is 10 raised to the power 6 plus 20 because log of 10 raised to the power 6 is 20. So 10 raised to the power 6 plus 20 is what? 10 raised to the power 6. So n plus log n will be order of n. This is the space complexity. Can I say that, guys? And this we figured out by checking that at any point of time, our space will never be more than that. And do you remember that's the worst case? That your algorithm performs as bad as what? Here, the arrays will be as big as 3n or less than 3n. Can I say that? Can I say that? That's the agenda, right? So read this article. Read this article, everyone. Okay. And if I share it with you here, you can see the author has given more examples as well, right? For example, even for 64, if you try to do it for 64, you will always realize that the total space that you will take will be less than equal to 3n, right? So when your algorithm performs as bad as 3n, we can say that the space will never be 3n for the arrays and log n for the call stack. So kn plus log n, where k will be less than equal to 3, is what? Order of n. How many of you guys are able to get this point? So this is also one way in which you technically analyze space complexity and time complexity, right? That's why I said for every question from now, we will be analyzing time and space. Because just think about it. Without these algorithms, how can I actually bring these questions in the class, right? So do you understand? So final verdict. Time complexity in all the cases of merge sort is n log n, and the space complexity in all the cases is n. Make sense? Make sense, everyone? Yes, Gaurav. So what are we saying? It will be something less than 3n. What? We don't know. It can be 2.7n, it can be 2.8n, it can be 2n, it can be n, but it will never be more than 3n. And that's the worst case. We try to figure out if it will be bad, how bad it can be. That's the worst case, na? Remember linear search? Linear search can be as bad as n. You can never do more than n there. You can never do more than n iterations there. Can I say that? Make sense? And the call stack size is the number of levels because on each level you make a recursive call. For each level you make a recursive call. So at any point of time, how many recursive entries will be there? Log n recursive entries will be there. And why we are considering call stack, guys? Now that's also an interesting fact. Why we are considering call stack? Because we always consider those things which can grow with the value of the size of the input. Now just think about it. If the length of the array is 1000, call stack or number of levels will be log of 1000, that is 10. But if the array length is 10 raised per 6, log of 10 raised per 6 is 20. There will be 20 call stack levels. Can I say that? So are you able to visualize that with the change in value of n, call stack size is changing? So So it is not constant. So we do need to consider it. Are you guys able to get this point? Are you guys able to get this point right? Now, one very interesting question came up from a student. Sir, why again and again you are taking log base 2? Why not log base 10 or log base e? So first thing, taking log base 2 was going to make our calculation easier. That is the first argument. I have multiple arguments. Taking log base 2 was going to make our calculations easy because here we were playing with the power of 2. Are you guys able to get this point? Are you guys able to get this point? Okay. Now there is one interesting, this is the first argument that I have to give. This is the first argument that I have to give. Now there is one more argument. There is one more argument to this. You can log नहीं आता है 11-12 में मैथ्स थी तो फिर लॉग आना चाहिए ना 11-12 की बुक्स पढ़ो उसमें लॉग गिवन है ठीक है ओके नाउ one interesting thing if let's say you have a value log n base 2 if you have let's say log n base 2 okay what you can actually do is we can very easily convert it to any other base we can very easily convert it to any other base anybody how can we do that so let's say if you have log x to the base a if you have log x to the base a you can convert the base a to base b by doing log x to the base b divided by log a to the base b. This is the formula. So for example, here you have log n to the base 2. If you want to convert this base 2 to base 10, what you can do is you can write log n base 2 as log n base 10 divided by log 2 base 10. Are you able to get this point? And can I say log 2 base 10 is constant? Can I say it's constant? Can I say that? Any base you can do. For example, log n base 4, if you want to convert it to base 5, you can write it as log n base 5 divided by log 4 to the base 5. Can I say that, guys? And this value is independent of n. Can I say that? The denominator is independent of n. It's a constant. Yes or no? Yes or no, guys? It's a constant, right? It is not having any factor of n. See? If I write it as n. Okay? So can you see the denominator has no factor of n? So it's a constant, right? So in big O notation, eventually it is going to get avoided. In the big O notation, it is eventually going to get avoided. That is why a lot of time you will find people writing n log n without a base, without any base. If you will read standard foreign author books, you will realize that they do not write bases. They just write log n because you can put any base here. You can put base 2, you can base 3, base 4, anything because whatever base you write, I can convert that base to another base by multiplying it with a constant. What constant? This constant. I will multiplying it with 1 by this. Can I say that? So constant multiplication can change the bases. So that is why in big O notation, big omega notation, big theta notation, all these complexity notations, you do not write base of the log. And why we used base 2? Because we were going to play with the multiplicative factor of 2. Are you guys able to get this point? Drop a quick yes or no in the chat.